Welcome, everyone. My name is Marnie Trujillo, Market Industry Manager with Keysight Technologies, and I'll be your host for today's virtual seminar entitled Challenge the Expert for USB 4, brought to you by Keysight Technologies. We are really excited that you're joining us for the first event in our Challenge the Expert series. We are privileged to have Jit Lim be our USB 4 expert today. And I'll get over to him real quickly. Jit, over to you.
Hello there. So first, the disclaimers. For whatever reason, the presentation doesn't have the disclaimers. But first, USB 4, USB Type-C, and USB-C are trademarks of the USB Implementers Forum. Thunderbolt is a trademark of Intel. And finally, VESA is a registered trademark, and DisplayPort is a trademark of VESA. So those are the disclaimers that are really important. I'll go to the next slide here. And since it's tiny, I'm going to go look at the other presentation. So we'll talk about the technology overview and timeline, a review of the architecture, testing challenges, lessons learned, and a solution summary. But as Marnie said, this whole session is about you. So we want to focus a lot of this in a Q&A. And the reason is because in the audience, there'll be some of you who just got told maybe last week, you shall work on USB 4. And there'll be some of you that have been doing, say, Thunderbolt 3 USB testing for the past decade. So I think the most efficient use of our time is to really spend time on a Q&A section. The USB 4 was announced by the USBIF in March of 2019. And literally 6 months later, the spec was released in September of 2019. And the reason for the really quick introduction from announcement to spec is because it's based on the Thunderbolt 3 protocol. Some key highlights is that you must use the Type-C connector. That's one of the questions you get quite often. So if you've been doing USB 3.2, say, by one mode, you could implement using a standard A or a micro B or even a standard B connector. You can no longer do that. You have to use a Type-C connector for USB 4. There are two independent 20 gig lanes. They're bonded to one logical 40 gig lane. There is a variant. You can actually do two independent 10 gigs bonded into one 20 gig lane also. USB 4 will support other standards to alt mode. And I'll talk about the various modes that a USB 4 product needs to support shortly. So the first thing you should do is get hold of the USB 4 spec. It's publicly available to everybody. And so you should just go download it. And in particular, pay attention to, I'm trying to think, for compliance testing, I think section 8.3.2.1, I believe that's the chapter that describes how you should implement your USB 4 silicon and system in particular to be able to leverage the automation. Okay, so in the USB 4 spec is section 8.3.2.1, if I'm not mistaken. Let's see. Next slide here. I'll look over here too. The CTS, that's the compliance test spec. It's at version 0.96. The USBIF plans to release this in Q2, the final version 1.0. So it's still in a draft version 0.96 today. And at a high level, the PHY testing is very similar to Thunderbolt 3. It has transmitter testing, receiver testing, and return loss testing. Also talks about active and cable testing, which is a critical part of the ecosystem, plus the other technologies that must be tested, including Type-C, PD, DP, and USB. This document is not publicly available, but there's a very high likelihood that someone in your company has access to the CTS. And if not, you should request to be added to the USB4 working group within the USB-IF, which then allows you to access the compliance test specs. So that's what you should do to get an early draft version of that document. Next slide is the architecture overview. This is an important slide. We get lots of questions about, what you can or should or shouldn't test. So there are lots of pieces in here. So at a high level, you need to test USB 3.2 at 5 and 10 gig. And this is native mode. So if you look at the block diagram, it'll be the enhanced super speed host, I think. I can barely see my slides. Let me see if I can make that bigger myself so I can actually see that. It's the host silicon that comes directly out to the Type-C port. So that's one mode. If you look at the right side of the slide, there's a block diagram that says USB 2. I think it says USB 2 host. That's the host silicon. It also is native. It comes out of the Type-C connector in native mode. On the left of the block diagram, you see something that says DP. I think it says DP source. There's no line that goes from the DP source to the Type-C, but it's required at least, I think, for the first year or two. And it makes perfect sense, right? If you have a host, if you ship a USB host, there's a high likelihood your customer will connect it to a DP sync. So I believe the USB 4 spec requires it, at least for the next year or two. And it makes perfect sense that you need to have DP alternate mode or DP native mode, if you will, that comes out directly to the Type-C connector. There is this notion of tunneling, and we get these questions a lot, which is, do you have to test PCIe when you're implementing USB 4? So the answer is you don't test it at a Type-C connector. We do for tunneling. So we do we test the protocol for PCIe on a Type-C connector through tunneling, but there's no PHY. In other words, the PCI signal at I believe it's Gen 3 does not come out the Type-C connector. So you will not see PCIe 8 gig on a Type-C connector. What it does, it goes through an adapter and it's tunneled. So when it comes out through the Type-C port, it looks like a USB 4 signal. Similarly, the USB 4 host needs to tunnel DP up to the HBR3 rate, and it can also tunnel USB 3.2, which is a new requirement. So if you did Thunderbolt 3, you couldn't tunnel USB 3, but in the USB 4 spec, you need to be able to tunnel USB 3.2 in addition to running in native mode. So, and the other thing is Thunderbolt compatibility. I believe there is also a requirement to be able to provide Thunderbolt 3 compatibility also when you ship a USB 4 host. And I believe there's a high likelihood that it's public now that it'll be a Thunderbolt 4 when you ship that product. Okay, so lots of different technologies that must be implemented, lots of different speeds. And one of the questions get asked quite often is, well, what if I just tested the port for, let's say, Thunderbolt 3 at 28.625, which is the highest rate we know of being put out through the Type-C connector. If I test at 20.625, then perhaps I don't need to test USB 2 at 480 megabits. And the answer is not because of the bit rate, but because they have different use cases. The cable loss models for USB 4 at 20 gig or Thunderbolt 3 at 20.6 are completely different from a USB 2 cable, hence the need to test all these different standards. Let's see, looking back over here, switching to this. So again, another question that we get asked all the time, how different is testing USB 3 and USB 4? But the short answer is completely different. Even though they're called USB, the methods are quite different, mainly because it's based on the Thunderbolt 3 methodology. So, for example, the first bullet, you have to do return loss, TX and RX. We never had to do that in USB 3, but it's required for USB 4. So that's new. In USB 3, we never had to calibrate or do anything with the TX EQ. For one thing, there's only one TX EQ. Well, it's much more complicated. There are 16 presets TX EQ for USB 4. So not only do you need to calibrate and test them, you need to find the optimal one that creates the best eye opening. So that's also different. No surprises there. The receiver equalization is quite different. It's got a single tap DFE and a 10 gain CTLE. So that's also quite different. It also needs to be calibrated, and the optimal RX EQ is required. No surprises, the bit rate went from 10 to 20, and the signaling is on all 4 Type-C pairs. Now, if you do by 2, you realize that you have to get it done into by 2 mode, where both lanes are running in parallel. For USB 4, it's always in this 4-lane test mode, but the crosstalk is done using a separate source. You need to de-embed the test cables, and the reason is there is very little margin. I think we all remember the days when we first started testing 5 gig and most products failed. And of course, we all went to USB 3.2 Gen 2. We started testing 10 gig and early silicon. A lot of products failed. Unfortunately, at 20 gig electrical, it's going to be very challenging. And so every bit of margin matters. So we need to de-embed the test cables, the new insertion loss budgets. There's a very high likelihood that when you implement your USB 4 designs, you'll be forced to do some kind of a repeater, whether it's a redriver or a retimer. And there are very specific measurements for retimers that are in the draft CTS that need to be made. So just a heads up on some of the more difficult challenges. As I mentioned earlier, there is new crosstalk requirements that did not exist before. And the proposed new controllers and fixtures for USB 4 should do that, provide a crosstalk. There are new jitter measurements. I think I'll spend some time on that next. New phase and slew rate measurements, skew measurements, although I think the latest version, going from 0.95 to 0.96, I think they removed the skew measurements. So like I said, things are evolving a little bit. We get lots of questions about LTSSM. In a live link, there's link training done by a USB 4 product. But during testing for electricals, we do not use LTSSM. So the method that is proposed for USB 4 removes the notion of LTSSM, removes the TX and RX also. Let's see, I can hear some typing going on, so I'm not sure if somebody's not muted or how the new tool works, but I can actually hear typing going on here.
I'm sorry, Jit, that was Marnie. That's not good. I had unmuted myself. I was going to give you a time hack. We're 18 minutes into the series, so I just wanted to give you that time hack. So sorry.
Oh, okay. And how do I tell where the time check, where does it come into?
Oh, I'm telling you. So you don't have to pay attention to it. You can just focus on your slides. But I just wanted to let you know. Yep.
That's good to know. Thank you, because we really want to focus on the Q&A. So I'll go even quicker through these. So lots of jitter cocktails because of the short channel, long channel, 10 gig, 20 gig requirements. Okay, so thanks for that heads up. Let's go to the key challenges. The PHY is much more complex. No surprises there. The test method is more complex too. Okay, it's completely different from USB 3. So if you've been doing USB 3, in a sense, you can forget most of what you've learned. You got to learn how to do new techniques for USB 4. The insertion loss budget. I think for most of us, especially in silicon systems integrator, this is a really important chart because we spend a lot of time trying to figure out, especially in the early days, right? What do you embed? So on the top is the insertion loss chart for the 5 and 10 gig USB standards. And then, of course, at the bottom right is the insertion loss budget for the 10 and 20 gig USB 4 standard. And you can tell it's quite different. So, for example, you may say, for example, in 10 gig, hey, look, I've got a, 12 dB of loss on the cable. Great for the cable vendor, but if you notice, you lose that budget on the host or device side, and you need to embed a lossy cable and device. So this is a really critical chart for all of us, especially those of you doing silicon. Next chart here. The test points that matter are called TP2 and 3, and the diagram could be a little confusing about what it really means, but the words really matter. So TP2 is a short channel for TX, and TP3 is a long channel, which includes the RX equalization. So it may not be clear from the schematic, but the words are very clear about what you should do for defining the test points. Okay, so let's see. Back to this slide, transmitter specs. Some of these specs are very familiar to you, like the voltage I, SSC, rise and fall times, although the rise and fall times is 10 picoseconds. So that's a very difficult number to meet if you don't have the right equipment. 10 picosecond minimum rise time. You have the traditional TJA, DDJ, UI measurements, and there's some new, what they call uncorrelated. So for many years, well, at least let's use USB 3.2 as an example. We did jitter decomposition with random and deterministic. In the USB 4 world, the split is done by correlated and uncorrelated. So those are the key differences between the two standards. As I said before, there's a new return loss measurements. This is probably going to be one of your most difficult challenges, which is TP3. TP3 is a long channel use case. So if it's 10 gig, the customers will be using a 2-meter cable. If it's 0.8 meters, the customer using if it's 20 gig, the customer is using a 0.8 meter passive cable. And that provides significant stress to both TX, RX measurements. So just a heads up, the long channel use case, or rather the passive cable long channel use case is going to be very difficult to test. As always, the receiver testing is much more complex. You have to test at the 10 and 20 gig rates. And for those who are doing Thunderbolt, also, there are 4 rates, which is 10, 10.3, 125, 20, 20.625. Then you have the no channel or short channel use case, and then the long channel use case. So lots of different cocktails to set up. This is going to be very complicated. So I mentioned earlier LTSSM. It does exist in USB 4, but it's not done through the TX-RX lanes. So on USB, the sideband pins of the Type-C connector were not used. They are required in USB 4. And so the negotiation is done, the back channel is done over the sideband. And so you need to be able to look at both the sideband signals in parallel with the high-speed lanes when you're doing the link training and link optimization. Okay, so this is just a very brief overview of the Keysight solutions with a USB 4 transmitter test software, a USB4 receiver test software. We have a portfolio of USB PD solutions. We have introduced a new USB4 Type-C active link fixture that allows you to access all Type-C signals on a live link. We have introduced a USB4 low speed, this is the low speed sideband protocol, and a high speed protocol. You see eUSB2 here, so there'll be some implementations where you are looking at USB4 silicon, where the USB 2 signal will be implemented using eUSB2 for the lower voltages. So we have a solution there also. And finally, the return loss software for doing return loss for on the TX and RX. Finally, the very last slide. So this is the Type-C Keysight Solutions Matrix, clearly design simulations, solutions, protocol decode, PD solutions, RF for the Type-C connector, channel characterization, which is on the board and between the silicon and the Type-C connector, sideband, Thunderbolt display. We have the transmitter test. We recommend the UXR platform because of the low noise and the margin. Very low, 1 millivolt RMS and 25 femtoseconds. The ENA for the cable connector return loss testing, and of course the BERT and the BERT software for the receiver testing. And with that, I'm going to turn this back over to you, Marnie.
So we do have a number of questions. Thanks so much, everyone, for submitting those. So we'll see if we can challenge Jit. Again, if you have questions throughout this, we'll answer those as best we can, and if we don't get to them, we'll address them afterwards. So Jit, your first question is, do USB, this is from Kevin from On Semiconductor, do USB4 devices need to support DP 2.0 alt mode?
So that's a fantastic question. It's, even though it's not stumping, but I think it's a great question. So I think the question is, does a USB4 host? So, right, it's probably a host, not a device, because generally a USB4 or a DP device, which is a source, doesn't need to support other technologies, because if you're just a display device, you can only just do, say, USB4 or DP. So let's assume that the question is, does the USB4 host need to support DP 2.0 alternate mode? So at the USB IF Dev Days, I recall, and I agree with it and it makes sense, that a host should support DP. What was not clear was which variant. I believe the requirement then was it needs to support DP 1.4 up to HBR3, which is the standards that today traditionally run over the legacy VESA DisplayPort connector. So, so I think the answer is you should support DP up to HBR3 over the Type-C connector in alt mode. I think the DP 2.0 spec, I know the spec is announced. In fact, it is. So VESA has publicly announced that DP 2.0 will adopt the Thunderbolt 3 spec. And I think they mentioned the rates in 10 and 20 gig too. So there's no secrets here. So I don't think there's a requirement, but I think it'd be optional for a USB4 host to support DP 2.0 alt mode at the 10, the 13.5, and the 20 gig rates. But I would think that one would need to support the lower rates. So hopefully I answered the question.
A real quick question, again from Kevin. Will USB4 devices be tested for TBT3 compliance?
Wow, that's a good one. So let me make sure to answer. I think the question was, will USB 4 devices be tested for Thunderbolt 3 compliant? So it's public again. If you look at the USB 4 spec, it actually mentions Thunderbolt 3 rates in the USB 4 spec. So this is public information. So if you read the USB 4 spec, it says it's rates of 10 and 20 gig, but it also says the optional Thunderbolt 3 rates are 10.3 to 125 and 20.6. So the question comes down to, what is your implementation? I believe that most hosts will implement the USB 4 rates of 10 and 20 gig and the Thunderbolt 3 rates of 10.3, 125, and 20.6. So to answer your question, the answer is yes. You will need to test the USB 4 spec rates of 10 and 20 and the USB 4 spec rates that include the Thunderbolt 3 rates of 10.3125 and 20.625. I know this is very confusing, but it's all in the publicly available USB 4 spec. Another tough and great question. Thank you, Kevin.
Okay, next question is from Pascal. Can the insertion loss be measured with the Keysight E5071C?
I'm going to guess this is a Pascal I know. So the answer is no, Pascal. You need to buy the 5808B. No, I'm just kidding, Pascal. But if it's not the same Pascal, I'm sorry. So the answer is yes, Pascal. You can use the antiquated old E5071C to do the insertion loss measurements. We will still support that, although I strongly recommend you upgrade to the E5080B, Pascal. So great question, Pascal Dasqueta.
Okay, great. Let's see. Hopefully this question makes sense. This is from Aurelio. Merlos, he asks, software needed, Valiframe and link training. Does that make sense? And if not, if it doesn't make sense, Jit, I can ask Aurelio to.
No, it's a perfect question. No, it's a good question. So, hi, Aurelio. I think this Aurelio I also know, maybe not, but regardless, it's a really good question. So I'm going to go back to the slide 15. I'm not sure if it's, can I push it? I'll try and push it. Let's see. If it's, I'm sorry. If I can push it, great. If not, I'm sorry. But I think the slide's available. So the answer is, the first part is Valiframe. So it's a second bullet. It's, Aurelio, it's N5991U40A, USB receiver test software. So that's the software you need. And you mentioned link training. So that's another fantastic question. For that, Aurelio needs to get two. So in the USB 3 world, we had a whole bunch of additional software tools that help with something called link training, which is the steps that's required to go to the LTSSM state to get that data into loopback. USB 4 silicon is required to have the error detector built in, and the USB 4 receiver methodology requires that we put the product into the BERT testing mode directly without going through the sideband LTSSM. So the answer is there's no LTSSM software option because there's no need to go through the link training state to get into to test into the test mode. So the only time you worry about link training, it would be in bullets, the bullet that says sideband decode. That's when the live link is being used, but it's not required for compliance testing. So another great, tough question from Aurelio.
Okay, Jit, next question is from, oh boy. I apologize for mispronouncing your name, but I'm going to try it. Aham Zude. And shoot. So Aham asks, are the test fixtures already defined? Are they very fragile? Should different test fixtures be used for each speed?
So it's actually a good question. Could you repeat the first part of the question, because it's a multi-level part question again? Can you repeat the first part?
Yeah, this person asked multiple questions here. So are the test fixtures already defined?
Okay, let me answer that first, so then I can. Within the working group, there is a set of proposed test fixtures that we are working towards, but the USB-IF will need to announce the test fixtures. So that's the first part of this first question. And the second part of the answer is, in USB 3, there's no notion of a controller. So in addition to the test fixture, there'll also be something called a USB 4 controller. And its job in life is to put the product into these test modes. So in USB 3, we use the LTSSM process to go into compliance mode. In USB 4, we use the test controller to get the product to, say, put up PRBS 15 or 31 or to do the BR test. Okay, so it's different. It's defined within the working group, but it's not announced by the USB-IF, the test fixtures, and this new thing called a controller. Fantastic question. And sorry, Marnie, now can you get to the rest of the questions, because there's something else?
Oh, sure. Let's see. He wanted to know if it was very fragile. And then the last part of the question is, should different test fixtures be used for each speed?
So as far as the second question about it being fragile, I think I would say in general, when you get to 10 gig, 20 gig speeds, the physical structure has to be small, period. Large structures like we have for USB 2 or USB 3.0, even at 5 gig, they just don't have the signal integrity. So unfortunately, when you get to the 20 gig speeds or 10 gig fixtures, they're much smaller, and when they're smaller, when you have small physical structures, they tend to be more fragile than a large physical structure. And the last question was just a really excellent one. Do we use different fixtures for the different speeds? The answer is no. There should be essentially a plug fixture. There's a variant of that. There's a receptacle fixture. There's also a variant of that. But those plug and receptacle fixtures should be applicable to all 4 USB 4 speeds that are documented in the USB 4 spec. Fantastic question.
Okay, so if this person is still on the line, this is really more of a clarification question for you. The person's name is Haiyu, H-A-I-U. Apologize if I mispronounced it. He asked 2 questions. The first one is, is USB 4 testing available with 5G testers, integrated 5G testers, or is it a separate equipment needed? And then he sent a following message that he says, I mean test integrated with hardware E7515B UXM. So I think he's asking if you can do USB 4 testing with the UXM. I believe that's the question.
Okay, yeah. So assuming the first part, 5G testers, meant the 5G USB rate, let's assume that's the first question. Then the answer is maybe not. So a USB 4 tester at 10 and 20 gig can be used to test USB at 5 gig, but a USB 3.2 Gen 1 5 gig tester may not have the performance to test USB 4. So that's assuming by 5 gig how you meant the USB testers. Now, the UXM is a 5G RF tester. So the answer in that case is it wouldn't work. The UXM is quite a different instrument. Its job is to test the emerging 5G wireless standard, and it's really not applicable to USB4 testing. It's a great question. That's the closest to getting me stumped. So
got another good one here for you, Jit. This is from Narciso. Do we need to test USB4 with a 4-channel scope? And in parentheses, both 2 lanes connected to scope, or can we connect only 1 lane and terminate the other one?
It's a great question. So the question was, what's the requirement for 4 and 2 channel? So the requirements are changing a little bit. So as I alluded to earlier, in an earlier version of the CTS, there's a notion of a skew measurement. So when you do a skew measurement, you almost have to have a 4-channel scope, because you got to put the plus minus, let's say, into a pair, and the other plus minus into the other side. So there's definitely a requirement to do that. If you look at the draft copy of 0.96 of the CTS, it actually says you need to have 80 gigasamples on 4 channels. So on, I think it's page 1 or 2 of the CTS actually says you need to have a 4-channel 80 gigasample scope to do that. To be honest, what's not clear to me is why, with the skew measurements being removed, is the need to have a 4-channel scope. So I think the answer would be, I think we need to maybe wait for the final copy of the CTS to determine the requirements. If 4-channel is absolutely needed. Today, the CTS says you must require it, but it's not clear to me which test requires it. So I think, Ronnie, I guess this question would be one that I would say stumped me, because I don't have a definitive answer, because there's still some more clarification that needs to be done. So just a great question.
Okay, great. Thanks a lot. We have a few from Joan, so I am going to ask her a question. What's the additional number of connection wired inside? For example, if USB 3.1 has 6 wires with red, black, green, white, and purple, orange. Does that make sense?
Yeah, it's a great question. So there are a lot less pins in the traditional, say, A connector or the B connector. And then when USB went to SuperSpeed or SuperSpeed Plus, they added the additional pins, high-speed pins to the connector. So the connector got bigger. If you look at the B connector, most of it don't, but there are 2 kinds. There's one with like a blue color. It's not always there, but you'll find on a blue connector, it looks a little bit bigger. But Type-C added even more pins. So Type-C has 24 pins. I'm trying to see if, unfortunately, I didn't have a Type-C connector pin out. I need to remember to do that next time. So, the answer is there are 24 pins. This is from memory, which is scary. There are 4 V-bus pins. There are 4 ground pins. No surprises there. There are 4 USB 2 pins, which are, shall we say, dedicated on the host side. So it's D plus and minus in one direction, and you flip it D plus and minus. So that's another 4 pins. There are 2 pairs of TX RX pairs. So there's TX 1 plus minus, RX 1 plus minus, TX 2 plus minus, RX 2 plus minus. So you get 2 TX pairs going and RX pairs going in parallel in both directions. There is the SBU pins, sideband pins that are used and required for USB 4, not used for USB 3. They're used for the link training. So that's another 2 pins, SBU 1 and SBU 2. And finally, going from memory here, I've got this Type-C connector in my brain. I'm trying to think. It's the CC pins, the CC1 and CC2, and that's used for setting up the the PD contract. So those are the 24 pins. They are not, the information is not in the USB 4 spec, the detail you're looking for, but you should Google, just Google, look for the USB Type-C specification, which is also publicly available. And there you will see the 24 pin outs for the host, receptacle, or a plug. So that's where you would see all 424 pins. I think I got them all that are different from your legacy A, B connectors. Great question. So
we've got another one from Joan. She asked, if the color of USB 3.0 is blue on connection type A, will there be a color designated attached to the USB-C 4? Size is different from USB-C, USB 3.0.
It's another great question. So Joan is listening really well. So yes, on the USB 3.2 standard A and B connectors, there's this blue plastic in there. It's not always true, but they sometimes would do this blue color. On the Type-C, there will not be a color. There will be no blue color, but there will be a new logo. So I think it's also publicly available. When customers ship USB 4 products, there will be two variants. There'll be a 20 gig variant, which is 10 by 2 USB 4, and there'll be a 40 gig variant, which is 20 by 2. And they both have a special logo. So we should see this logo on the labeling. We should see this logo on your products also, like where the trident is, you say 40 gig or 20 gig. But I do not believe the USB IF will add a color to the Type-C connector. So it's a really an excellent question. Thank you.
Okay, are you sitting down?
Yes, I am. I am still here.
Okay, because we have one we think that might stump you. So here it is. This is for Mayam. Again, when applying for logo, should we pass with or without a retimer redriver, or need to pass both conditions?
I think this gentleman, Am, is someone I know. So hello, and definitely a really tough question. So let me understand. Could you repeat the question again so I'm very clear because of the question?
Yeah. When applying for logo, should we pass with or without retimer/redriver, or need to pass both conditions? I might not have asked it. He wrote rediver, but I'm assuming he means redriver there.
Yeah, it's a really, really excellent question. So we're going to assume the question is on a host or device product, not say I guess it doesn't matter. Let's just focus on let's assume it's not a component retimer or component redriver. Let's assume it's not a cable. Let's just assume for now that this product is a integrated big product like a host or a device. The answer is if the signal path has a retimer or redriver, it has to be it's tested as part of a signal path, if you will. It's a great question because prior to having these retimers, we tested a host or device as a black box. In other words, we didn't care what it had in there. But for USB 4, it's very specific. We have to ask, does the product have a retimer? If the product has a retimer, then we have to add additional tests. So we do the existing tests. For example, the usual JTOL tests and the I-height, I-width, etc. But if it has a retimer in the current draft version of the CTS, we have to add for both TX and RX the notion of clock switching. So on the TX side, we have to be able to do a clock switch test. Once we know that this product has a retimer built in, if the product is if we're doing a receiver test, then we also have to inject this unique SSC pattern that's also in the draft specification of the CTS to be able to stress the receiver because of this clock switch that's found in a retimer. Now, the slash was a redriver. If it's a redriver, then the answer is it is still, to the best, yes. We would still test it like a black box. A redriver, we would not do clock switch because redrivers don't have the notion of clock switching, either in a TXRX. So that is the complete answer to a great question about retimers and redrivers in USB4. Great question. Next question, Marnie.
Okay, we're running out of time here, but I will ask. We have got time for one more question. Let's see. This is from Mahesh. A USB 3.0 had interference at. Oops. Oh, shoot! We just had another one pop up. Let me ask Mahesh's question. USB 3.0 had interference at 2.4 Wi-Fi due to its 2.5 gigahertz spread spectrum clock. What are the risks of USB 4 interfering with 5 gigahertz Wi-Fi antenna sensitivity due to 10 gigabits per second signaling?
Yeah, a great observation. Another fantastic question. So yeah, the USB 3.0, the legacy ones, had some issues with that speed at 5 gig, which is 2.5 gigahertz fundamental. So the answer is the USB-C connector has a totally different mechanical design. And my understanding is that the USB-C connector is a lot less susceptible to the RF interference issue. But the point is well taken because the 10 gig version's fundamental is running at 5 gigahertz. So it's sitting right on top of 5 gigahertz fundamental. So the two things, one, like I said, is that the USB-C connector was designed to have much better RF protection, number one. Number two, there's another group in the USB IF that's working on RF interference. So there's actually a type C RF interference test that's done with a spectrum analyzer to determine the susceptibility of your product for USB 4. So those are the two responses to reduce the risk of 5 gigahertz interference at 10 gigabits. Great question, and Marnie, I gotta tell you, that almost stumped me also. So it's a fantastic question.
Okay, so this last one, I did say that we were wrapping it up. It is almost like 1 minute from the top of the hour, but I wanted to share something with you. Somebody named Amir sent over maybe a clarifying comment, and I thought you could agree or confirm this. So Amir said, refer to the first portion of USB 4 specs, chapter 3, section 3.1. And this is regarding the question about the retimer redriver. So a USB 4 router assembly is comprised of a router and up to 2 retimers placed between the router and the USB Type-C connector. A USB 4 router assembly may contain linear redrivers between the router and a retimer or between 2 retimers. If a router assembly contains linear redrivers, a retimer shall be placed between the linear redriver and the USB Type-C connector in order to meet the requirements in the section. So, yeah, it's really my colleague.
Is there a question,
here,
Marnie? Is there a question?
Is it more of a, can you confirm, does that address the person's question about the retimer? Sorry, I forgot that person's name. I think it might have been from.
That's okay. We're off time, but it is the spec. I haven't, I don't have the details, but the answer is yes. A USB, again, it's from memory, a USB host or product can have 2 repeaters. It could be, say 2 retimers or a redriver and a retimer. But the port-facing the repeater facing the port must be a retimer. In other words, you cannot go from, say, the SOC to a retimer, a redriver in port C. You have to, if you want to put a redriver, it's got to be SOC, redriver, retimer, and then the type C port. So the answer is yes. If that's the question, it's not clear to me what the question is. But the answer is basically when we do testing, we're essentially testing the last retimer, if you will, the one that's looking out to the type C port. Another way to look at it is we will never test a redriver because by spec, a redriver cannot be placed facing the type C port. So I'm not sure if that answered the question, but Marnie, that's a way for us to get back to the customer, right? If this is not clear.
We'll make sure we get back. And Amir sent a follow-up question. He said, the question is, don't you expect to have a retimer at each port? I think that's what he was trying to drive at.
Okay, so the quick answer is you must have you cannot have a redriver. You may have a retimer, but we can see implementations. Let's pick a simple one, right? A USB4 memory stick, for example, a memory drive where the silicon's right next to a USB port. For applications like these, you may not need a repeater, retimer, redriver because the USB4 silicon is sitting right next to the Type-C port. So it's not a requirement, but so there are cases where you will probably get by without a retimer or redriver next to the Type-C port.
Okay, I think Jit, you need to get a drink of water. We've put you to the test. So thank you so much for everyone who joined us. Again, this is the first in our series first in our Challenge the Expert series. We are super excited that we got to kick this whole thing off with Jit, Mr. USB4 in our circles, or Mr. USB. And thanks everyone for joining us. We really appreciate it. Thanks, Jit, and we appreciate your time and all of your expertise.
Thank you.
And by the way, there are a number of other questions. If we didn't wrap this up, I think we would have gone on for a long time. So any question that we did not get to, Jit will be responding to directly, and then we will also be selecting somebody to get an hour with Jit to talk about USB4.
Thank you all. Thanks, Marnie.
Thanks, Jit.